Hi everyone, in this video I would like to solve 4 different types of Fourier series example for you. As the first one, if we had f to the power of 2x. As the second one, if we have Fourier series and want to solve an integral. As the third one, if we have sine 2, cosine 3, sine times sine or whatever. As the fourth one, Fourier series of a function is given and they want Fourier series or a function of a Fourier series. That's it. As the first example, it is said that to solve this problem, periodic function of f of x in a period is given as f of x equals 1 if it is between minus alpha and alpha, equals 0 if it is between minus pi and minus alpha and alpha and pi. Also, alpha is between 0 and pi over 2. If Fourier expansion of function be like f of x equals this equation, then find the result of below series. Summation of sine n alpha over n to the power of 2 from n equals 1 to the infinity. Firstly, we should find out the Fourier series coefficient. This is a naught. If I multiply 2 over pi times this, sine alpha will become an. All of these are an because these are cosine and pi over L. So these are an. This times this will become an. This is a1 for instance. Okay, we simply write it down. A naught over 2 equals alpha over pi. Then a naught equals 2 alpha over pi, and an equals 2 over pi times sine n alpha over n will become 2 sine n alpha over n pi. And finally we should find the L. N pi over L equals n, then L will become pi. That's it. Okay, when you saw to the power of 2 in our equation, our relation, you should remember our Parseval's identity. I will write it down for you, this relation. Parseval's relation look like this. 1 over L integration from minus L to L of f of x to the power of 2 d of x, which is a naught to the power of 2 over 2 plus summation of an to the power of 2 plus bn to the power of 2 from n equals 1 to the infinity. This is the Parseval relations, and it should satisfy the Dirichlet condition. Dirichlet condition it look like this. Value of Fourier series in the point of x equals a naught of a function of f of x equals f of x naught, which is positive, plus positive side f of x naught negative side over 2. It should be itself a continuous function. We should not see any incontinuity. This is Dirichlet condition. It's just a substitution. We should consider x from minus alpha to alpha because it is 1 and the rest of it is 0. Also bn is equal 0. Okay, we have a naught and an. Substitute in the parcels relation. We'll have L1 equal pi also. We'll have 1 over pi from minus alpha to alpha integration of 1 to the power of 2 d of x equals a naught, which is 2 alpha over pi to the power of 2 over 2 plus summation of an, which is 2 sine n alpha to the n over n pi to the power of 2, n equals 1 to the infinity, which is will have its integral is x alpha minus alpha. That's it. And we exponentiate it. It's 4. We cancel out one of the 2's. Will become 2 alpha to the power of 2 over pi 2. And we factor out the 2 from that parenthesis and to look like this: 4 over pi 2 summation of n equals 1 to the infinity of sine 2 n alpha over n 2. We can see that this equation, I call it I, equals this, the desired series. Just a change in order, we move this equation here and this to that side, and we'll have 2 alpha over pi minus 2 alpha 2 over pi 2 equals 4 over pi 2i. We just take a common denominator. We'll have pi 2 and 2 alpha pi minus 2 alpha 2 equals 4 over pi 2i. Cancel out the pi 2 and simplify by 2 will become alpha times pi minus alpha over 2. If you want full explanation of Fourier series, watch this video that I put here. Okay, in this problem, they have given us a Fourier series and they want the outcome of an integral. It is not said what is f(x) actually. They have given us just this Fourier series. We have sine to the power of 3x. We have a relation for them, which is like this. I write it down here. Sine to the power of 3x equals 3 sine x minus sine 3x over 4. They call this inverse problem. We used to have the f of x to get to this Fourier series, and now we have the Fourier series and they want an integral. We are turning back. We just have Bn. This is Bn. 1 over n2. Our Fourier series is time, meaning that an equals 0. We just have Bn's. Bn equals 1 over n2. I use the definition of Bn, which is the coefficient of Fourier series. Bn we had equals, and it is an odd function, 2 over pi from 0 to pi of f of x sine n pi over L, which is pi x. This simplify pi, which is equal to 1 over n2. Then we just change in order to make this integral appear. I call this phrase a star. A star, which is integration from 0 to pi f of x sine nx equals pi over 2n2. Okay, if I put 1 instead of n or 3, what will happen? It will make this equation. We have 1, we have 3. We just come back to this phrase that is desired, and I call it I. I equals integration from 0 to pi of f of x times, I use that phrase, 3 sine x minus sine 3x over 4 d of x. I send out the 4 and divide the integral. We'll have 1 over 4 integration from 0 to pi f of x 3 f of x minus f of x sine 3x. This is dx. If I put n equals 1 and n equals 3, will become pi over 2 and pi over 9, pi over 18. That's it. And it's a substitution. And this integral was pi over 2. We will have 3 pi over 2. This is pi over 18. And we just multiply each other. I equals 3 over 4 times pi over 2 minus 1 over 4 times pi over 18, which equals 13 pi over 36. This is our solution. If we had cosine to the power of 3, what's the relation? It will become like this. 3 cosine x plus cosine 3x over 4. You should use this relation. You see, it doesn't need to solve this integral. We just make it appear where? In the coefficient. This is beyond the coefficient of Fourier series. For the third example, I brought you this one. If we had this function, then find out what is a is. You are watching, you see it, power of 2. What do you remember? Partial relation. Yes. And is it a Fourier series actually? No. It's just we are watching, we see power 2. Power 2 is not Fourier series. Fourier series must be in the simplest way. We had a relation for sine to the power of 2, which is equal to 1 over 2 minus cosine 2x over 2. We use this relation in this problem. If it was cosine to the power of x, we will have 1 over 2 plus cosine 2x over 2. I use this relation to make this function in the simplest way. We will have f of x equals sine 2 1 over 2 minus 1 over 2 cosine 2x, which is 2 times x over 2, plus 1 over 2 minus 1 over 2 cosine 2 times 3x over 2 plus 1 over 2 minus 1 over 2 cosine 2 times 5x over 2. Then we clean up the equation. We just summate this constant number, which is 3 over 2, and write down the rest of it. We have minus 1 over 2 cosine x minus 1 over 2 cosine 3x minus 1 over 2 cosine 5x. This is our Fourier series in the simplest way. This is A0, this is A1, this is A3, and this is A5. We do not have any Bn, which is equal 0. And the rest of An equals 0. We just have 3An and 1 A0. This partial relation was like this. 1 over L from minus L to L of f2x d of x equals A0 to the power of 2 over 2 plus summation of An to the power of 2 and Bn to the power of 2 from n1 to the infinity. This is 0, and we have An, some An and some A0. We will have A equals A0 3 to 2 over 2 over 2 plus summation of 3 and 5. We just have 3 more, which is minus 1 over 2 to the power of 2 plus minus 1 to the 2 over 2 to the power of 2 plus minus 1 over 2 to the power of 2. L equals pi in our relation. Then we just should multiply it by pi. We have pi times 9 over 2 plus 3 over 4 will become 21 pi over 4. This is our result. For the last example, it is said that if the sine Fourier series of g of x equals x to the power of 2, which is x between minus pi and pi, be like this, then find the main function of this Fourier series, this desired Fourier series. Firstly, we notice that this is an artificially periodic function, and you see that it is limited between two a and b. In the second step, we just substitute x to the power of 2 instead of g of x. We'll have this. We'll have x2. I move this 4 to the denominator. Pi 2 over 12 minus cosine x plus cosine 2x over 2 to the 2 minus cosine 3x over 3 to 2, and so on. This is a naught, which is a constant number, and these are the a n, which because it is the coefficient of cosine. This is a1, this is a2, and this is a3. In order to get to this desired phrase, we should integrate this equation side by side. Okay, this is cosine. If we integrate, it will become sine. We'll have x3. If we integrate, x3 over 4 times 3 equals pi 2 over 12x minus 1 over 1 sine x plus 1 over 4 times 2 sine x minus 1 over 9 times 3 sine 3x. It's a 2x, excuse me, and so on. If we take a look at desired function, we will see this is, if we call it a, this is minus a. You see, all of these are multiplied by a negative sign. Don't forget to put the constant of integration. We have integrated it as a constant, and because it is a sine Fourier series, it is 0. If we change its order, it will become a equals pi 2x over 12 minus x3 over 12, which is equal, if we factor from 1x and 112, will become pi 2 minus x2. This is our main function. Okay, if you have enjoyed this video, please feel free to subscribe to MakeUnion YouTube channel, and like this video and share it with your friends.